Okay, we're going to finish up the last little bit of lesson 1.4. The first thing we're going to do is decomposing functions. So they want us to create a composite function from a function that is given. So what we're going to do, if you remember correctly, if we had two functions, this means we're going to put the g function into the f function. So what they want us to do is create a g function and an f function that at the end of the day gives us the square root of x squared plus 5. There's more than one way to do this. I kind of like to work it backwards. I like to think about what was put in, and I like to think about where was it put. So for example, you could say that g of x is the x squared plus 5. It's what's underneath the square root. And then if we were going to put this function into the f function and replace all the x's with that, then the f function would be the square root of x. Because now, if I was to do f of g of x, that would tell me to do f of, okay, I created x squared plus 5 for the square root of x. So instead of the square root of x, I will substitute my x squared plus 5 in there, and I get what I started with. So this would be one solution to this problem. There's usually more than one way that you can do these, and this it's the case here as well. So I could also have done, okay, I'm going to make f of x equal the square root of x plus 5, and then if that were the case, my g of x, what I would have substituted in would have been x squared. So if this was the one that I had done instead, then the x squared goes in for the x, and I end up with the square root of x plus 5. So this is like, instead of forming a composite function f of g of x, we're taking a function apart and saying, this is what I would look like if it went backwards. So just to maybe take a look at one more example, maybe if you had h of x as x squared plus 7, maybe it's the absolute value of x squared plus 7, and then we can make the, if we want to make an f of g of x, then we could make f of x be equal to x absolute value of x, and we could make g of x equal the x squared plus 7, which would then lead me to my f of g of x would be equal to my h of x, because that's what would get substituted in. Next, we have a couple of terms. A relation. A relation is a general term for a set of ordered pairs. That's just a listing of ordered pairs. Every single function that we have, any of our regular functions, could be written as a set of ordered pairs. It's just an infinite list. If the relation has a single y value for each x value, then it's a function. So this would be the idea of the vertical line test. And a vertical line test is going to check to see whether or not you have two or more points on the same x value. So if it's a function, every list of ordered pairs is a relation. It doesn't matter whether or not it's a function. So I like this little example they put at the bottom. A function is a specific type of relation, just like a rectangle is a specific type of quadrilateral. So all functions could be written as a relation, but not necessarily all relations are going to be functions. If you're checking to see if ordered pairs satisfy a given value, all you're going to do is plug these in and see what makes it true. So I forget which one makes this one true. 2 squared, if you put in the first one, you'd get 2 squared times negative 5 plus negative 5 squared. And I think that's going to be This is 4 times negative 5. Negative 20 plus a, it works. So a works. Put the 1 and the 3 in there, you get 1 squared times 3 plus 3 squared. Is that 5? That's going to be 3 plus 9er, and I get 12. So that one doesn't work for this example. And then 2 squared times 1 plus 1 squared. Is that going to be 5? 2 squared is 4. 4 plus 1 is 5. So I think A and C works if I've done my math properly. Yeah, negative 20 and negative squared is, yeah, we're good to go there. Using implicitly defined functions. Implicitly defined functions. We had this come up at the beginning of chapter 1 when they asked, is it a function? Implicitly defined functions just mean the graph is made up of two implied functions. For example, if I was to solve this for y, I would take the square root of both sides and I would get y equals plus or minus the square root of x. Well, the two functions are y equals positive square root x and y equals negative square root x. Individually, this is a function, and individually this is a function. But I think if we graphed them on the same coordinate plane, they would end up looking something like this. The square root of x comes up like that. Negative square root of x comes down like that. Is the vertical line test going to pass that? I think not. Same thing with this one down here. If I was to solve for y, I get negative absolute value of y equals negative x plus 1. So I just subtracted the x over. Divide everything by a negative, I get absolute value of y equals x minus 1. Well, this is going to tell me that my y could actually be x minus 1, or my y could be the opposite of x minus 1, because if I'm going to take the absolute value, it's going to end up making it positive. So here's my 1, 2 functions. They're two implied functions. Individually, these are both going to be functions, but if we're going to graph them on the same coordinate plane, it ain't going to work. And the last one is very similar to the one that we have up here. If you subtract x and then take the square root, you're going to get y equals plus or minus the square root of 25 minus x. Well, if you're going to do the positive and the negative, you're going to get two different values, two implied functions. So implicit just means that there's more than one. I think there's a couple of these in your homework. You're looking for solving for y and writing what the two functions would be. That's it for 1.4. Next we're going to move on to 1.5, and that'll be in a separate video.